Today, my guest presenter is Mike Woodworth, the founder of Divergent Media. As the creator of both Edit Ready and Scopebox, Mike enjoys writing software that simplifies complex video production and post-production problems.
Hey, how you doing, Martel?
Doing pretty good. I'm happy to have you on our tutorial here. I know you've prepared for us an introduction to production, post-production, and delivery codecs, right?
Yes. So I want to just sort of go over what the various types of codecs are and why you would choose one for each of the different segments of your workflow.
Before we get into that, why is that important for content creators to understand the differences?
Well, it's important because no matter what you do, you're going to be using a codec when you're producing video. And so either someone else is making the decision for you on how your workflow is going to run, or you're optimizing your own workflow. So the more you know about this, the more you're going to be able to optimize going forward.
Well, it sounds like you're totally ready. So I'm going to pass it on to you. And then if I have questions, I'll jump in and ask.
Great. To start really simple, well, the word codec is actually a shortening of two words, coder and decoder. And essentially, it's a piece of software that's going to take a video frame and encode and decode it. And so what we mean by that is if I've got this frame of video and I encode it, to code that video is going to convert it into a digital stream. So anytime you have video inside your computer, it's in a digital stream, so it has been encoded. There's no such thing as a non-encoded video. And so a lot of people think that the word codec stands for compressor, decompressor, and they get this idea that uncompressed video isn't encoded, but it is. The definition is coder, decoder. So the idea is you're bringing your video in, you're turning it into a digital signal, and that digital signal can then be processed by your computer. Sometimes that signal is just a straight representation of the pixels. Sometimes it is compressed to lower your total storage space. And so if you take that video signal and turn it into a stream of bytes with an encoder, you have to be able to do the opposite. You have to take that stream of bytes and turn it back into a visual representation that people can see. And that's what the decoder is. And so a codec is a matched pair of these two. It's an encoder and a decoder that work together to round trip your video frame.
Now, a good question for you. So when somebody takes, let's take, for example, AVC HD, right, which is pretty compressed, and then they go ahead and encode it into, let's say, ProRes, they're not really improving the quality, even though it may be kind of a less compressed version, because you're going from a totally compressed to kind of a non-compressed. You're still not improving that quality, correct?
Correct. So when you go from one codec to another, the term is transcode. And what you're doing is you're basically decoding the video back into a video frame, and then you're encoding it into the new codec. And so when you do one of these transcodes from something like AVC HD to ProRes, the video frame that gets decompressed out of AVC HD is not the same video frame that you had when you encoded it to begin with. And so that video information has already been lost in the compression process. And we'll go through that a little bit more when we talk about post-production workflow.
Thank you.
So when you're choosing a codec, or when you're designing a codec, or when you're choosing your workflow, every codec has a series of trade-offs. There are a number of levers that the codec designer can pull to determine where this is going to fit into the world of possible ways to code something. And so you have very simple things like uncompressed, where all you're doing is bringing the video in. We have very complex things like H.264 or GVC, which are doing a lot of stuff to make the video much smaller. But every one of those things is a trade-off. And so the main trade-offs that you want to think about when you're choosing a codec are going to be the encoding complexity. So complexity is going to be, can I encode the video in real time? This is important if you're choosing a codec for a camera. What are the costs of that? So the codec that the camera manufacturer chooses is going to determine the cost of the camera itself and how much heat it produces, how much battery it takes. The decoding complexity is going to determine whether you can play it back in real time. You know, there are codecs that cannot be played back in real time except on the highest end machines or with specialized hardware. It also determines if you're going to drop frames when you do that, or if you're able to play backwards. There are codecs that are more difficult to play in reverse than forward, or more difficult to cut. And we'll go through those when we talk about the post-production workflows. And then there's the compression ratio. So there are codecs that don't compress the video at all. There are codecs that compress the video highly. That's going to determine how much bandwidth it takes to download it, or to transfer it from machine to machine, or to pull it off of the card from the camera. It's going to determine how long your download times are if you're putting it up on the internet. It's going to determine what type and what size of storage you need. So if you can have a small SD card, or if you need a large, fast SSD. And then, of course, there's quality. So every codec is going to have a different quality profile. So is it going to produce artifacts? Is it going to change your color latitude? So is it something that you can color correct later? Does it do what's called chroma subsampling, which is, we'll talk about a little bit later, but it will affect whether or not you can do things like chroma key in your video well. And then the last two are just sort of things to think about. They don't matter as much in most use cases, but codecs are designed by companies or consortiums, and they're going to be subject to the various business decisions that these groups make. So will the codec work everywhere? Is everyone allowed to have the playback? Does the software that you want to use with this video down the pipeline, does it work with this codec? Is there any sort of licensing or patent problems? So things like ProRes is a great codec designed by Apple, but because it was designed by Apple, the adoption on PC is not as good. And so if you want to do an end-to-end ProRes workflow, that may tie you to specific applications, especially on the Windows side. Likewise, there's been a lot of talk over the years about patent pools, and some of these delivery codecs like H.264 or HEVC have provisions that so far have not been applied much, but that say that if you're going to distribute your content in this format, you have to pay a licensing fee.
And a perfect example is what happened with Windows and the support of QuickTime, right? I think ProRes is having an issue because they no longer are supporting QuickTime on Windows.
Right, exactly. And anytime you're choosing a codec, you have to consider these sort of things, because we're not in the world now where you may be working on something and you choose a specific codec knowing that the video is going to be ingested, cut, laid off, and then you can just sort of get rid of it. There's other footage where it's going to be part of your asset library and you want it to be available next year, 5 years from now, 10 years from now. And so these questions become important because this is essentially a way of locking your video into a specific ecosystem. And so, like I said earlier, the first four are really the most important thing. And what's interesting about them is that they all play off each other. These four trade-offs are interrelated. So, for instance, the more compression that you dial in a specific codec, the lower the quality is going to be in general. Usually more complex, more modern codecs designed for delivery specifically are going to provide much better compression and much better quality at the same compression, but they're going to have higher encode and decode complexity. And so all of these things are interrelated. And so what I want to try to do today, usually when I talk about codecs, I really tend to get in the weeds about how the codecs are designed, how they work. But what I want to do today is just focus on this graphic on the right here and just go through sort of the symptoms of these codecs, like what choosing one of these codecs is going to mean for your workflow. So it's not, I want to sort of gloss over what the codec is doing inside and just talk about what the ramifications are of choosing one of these and why you would choose each one. So with that, let's sort of jump in. There are basically three types of codecs. There's uncompressed codecs, which is essentially just copying the pixel data into some intermediate format that can be represented inside the computer. There's INTRAFRAME and INTERFRAME. And those are two different ways of compressing the individual frames to create a lower bandwidth image for the same quality level. And so we can start looking at how this actually works out. So uncompressed is the simplest of the three codecs. It's essentially going through pixel by pixel and just recording the color values for each of those pixels. You're usually saving your image in one of two color spaces, either RGB, so a red, green, and a blue, or you can do a transform into a YCBCR, which is another color space. And the idea is you take the same three values, the red, green, and blue, and convert them into three different values, one of which is luminance, so basically a black and white image, and then two other channels. Those channels are CB and CR. They're color difference channels. And really all that does is lets us separate out the black and white of the image from the color. So those two color channels, they aren't useful to us anymore, but what they allows us to do is start to do the most basic forms of compression. You'll see the encode complexity and decode complexity are very simple because these are just copying the pixels into digital. The quality is lossless because we haven't gotten rid of any information, but you'll see that the compression and the quality are these little fudge marks here. And it's because you can start to lower the quality and gain some compression by doing this chroma subsampling. So once you've converted your image into YCBCR, you can toss some of the color information because the human eye is very good at registering intensity differences, black and white, essentially, but it's not very good at seeing color. And so you don't have to store as much color information. A lot of people will have heard of 444, 422, 420. These are chroma subsamplings. And the idea is you don't store color information for every pixel. You store it for every 2 or every 4 pixels. And you only store the black and white. So all those 2 pixels then both have the same color but different intensities. And so this is the simplest form of compression. The disadvantage of it is going to be that it takes a lot of disk space. It's very high bandwidth. So the compression ratios are so low that you're going to need very fast drives, you're going to need lots of RAM. But at the same time, this is what uncompressed is always what your video ends up in for display. So any codec you have is going to be transcoded on the fly into uncompressed to display on your computer. And when you're playing your AVC HD content, it's going to be decoded into an uncompressed format, and that format is going to be displayed on the screen. Now, there's a corollary here. There's another similar encoding style, which has become popular recently. Specifically, it was popular in DSLRs, and it's been pulled across into the video world by RED, and it's RAW. And so the idea behind RAW is just that we can save some disk space. We can get some compression in exchange for a little bit of decode complexity by transferring our images as raw instead of uncompressed. And the reason why that is because the standard single chip camera on the market is not going to shoot color information for every single pixel. It's doing what's called a Bayer pattern. And that Bayer pattern is individual photo sites inside that single chip have little filters on them. So they're red, green, or blue. And that red, green, or blue information is interpolated to get you back to an RGB signal, an uncompressed signal. And so what the guys at RED realized, which was a really smart idea, was when you're interpolating information, you're basically creating new information that doesn't exist in the signal. And so what they decided was right now the cameras on the market are interpolating this Bayer signal into uncompressed to then try to compress it. But the Bayer pattern takes up less space to begin with. So why don't we move that process of interpolation onto the computer, which means our files off the camera will be smaller. But the trade-off is that debayering has to be done at playback. It has to be done on your computer. Like all of these, you're going to trade decode complexity for better compression. Okay, so the next INTRAFRAME. This is where people start to think of codecs as codecs. This is compression now. So now what we're going to do is take a video frame and run it through a pile of math, run it through some code, and get a smaller representation of the exact same frame. How that's done depends from codec to codec, but the idea is take a frame, compress it, make it smaller. INTRAFRAME is the simplest way of doing that. You think of the early INTRAFRAME codecs were essentially image compressors. So JPEG, for instance, you think of it as the codec that's used for images on the web, and it's the exact same codec. The idea is that you take the frame through the JPEG codec and store that smaller version. And so video is just a series of frames, so you just have a series of JPEGs, one after another. Each frame gets moved into a JPEG. You store those JPEGs in a file instead of storing the original frames. The advantage to this is you get a much smaller file. So you're getting compression, you can use slower disks, you can store more information on your drive, and in exchange, you're going to lose some quality, and that's going to depend on the codec. So JPEG, DV, SRCAM, AVC Intra, XAVC, these are all codecs that do this. ProRes and DNx HD are designed, some of these are designed for on the lower end of the quality spectrum. So they take the image, and the idea is in general, you're going to compress it heavily to get a lower bit rate. Some of these are designed to keep more information, and some of these will do both. So JPEG, has a quality slider in most implementations. ProRes ships a number of versions. So they let you choose this trade-off between compression and quality. LT versus 444, for instance, from ProRes. The same is true of DNx HD. They have 36, 145, 250. And so you're going to get smaller files for some loss in quality. And also, you're going to have a higher encode and decode complexity. And one of the things to note here is that for almost all of these codecs, the encode and the decode complexity are both going to go up in sort of parallel. It's what's known as symmetrical performance. So it takes more time to encode, it takes more time to decode. And that's, for most video workflows, that's sort of the performance that you want. You want to see roughly the same performance for encode and decode. The third type is what's known as interframe. So interframe is building on this idea of intraframe. So interframe designers of codecs realize, like, okay, so what we're doing pretty good job here getting performance by taking a frame of video and compressing it. But if I look at the stream of images that I'm compressing, there's a lot of similarities between individual frames as well. So the first frame of the video is not that different than the second frame. You know, things may move left or right a little bit. The guy in the front might, flail his arms around a little bit. But for large swaths of the image, it's the same. And so what interframe tries to do is find those similarities between frames and compress them by removing them. And the way it removes them is it says, here's a frame, and then when it goes to draw the next frame, it has to refer back to that frame before. So it says, here's the second frame, and it's got all these things in common with the first frame. So reuse those, and then use this additional information. And that's great, because that lets us drastically lower our bandwidth. That gives us a much higher compression ratio. If I flip back and forth between interframe and intraframe, you'll notice the compression ratios go up, but the quality doesn't change. So the advantage of this is you get much better performance for the same number of bits on disk. So a file that's the same size when done in interframe is going to look better, or the corollary of that is a file that looks the same is going to be much smaller. Now, the trade-off for that is that your encode and your decode complexity are going to go up. So examples of these sort of codecs are MPEG-2, MPEG-4, AVC-HD, HDV, XAVC, H.264, HEVC, which is the new H.265. And so these are really the only three technologies in use for video codecs at the moment. And they all fall into these three categories of how they're like characteristics of complexity, compression, and quality. And so now we can start trying to slot these into our workflows and see how is this going to work for me as a video producer. And so there's three main stages of production. There's production, post-production, and delivery. And we'll go through each of them one at a time. So when you're in production, of those four criteria, the one that matters most is your encode complexity. Because if you're a camera, every frame has to be encoded in real time. You can't drop frames because you can't compress them fast enough. And everything else is up to the manufacturer to decide, or up to you to decide when you're choosing which camera you want. And so there's lots and lots of manufacturer differentiation. We've got everything from hundreds of thousands of dollar cameras down to, iPhones and GoPros. And what a large part of that differentiation is going to just be how they've chosen to pull these levers. And so one thing I'm going to change on the graphic here as we go forward is compression. Now we're going to think about as file sizes, because that's really, as a producer of content, that's what you care about most, because that has implications. Larger files take more time to move around, they take more disk space, and they take different kinds of disks, because in order to play back or to capture a file in real time, you have to be able to get the frames off of disk in real time, or in some cases faster than that. It's going to determine how many streams of video you can do at once, because you have to get all of the frames off your disk at the same time in order to composite them together or to cut them. And so going forward, we're just going to think of compression as file size, and we're going to flip the axis a little bit. So we're going to go back to those codecs, and we're going to look at how they affect our production stage. So not many people are going to be capturing uncompressed. There's just very little reason to do it. It's very expensive. However, RAW is a common workflow for people, especially coming from Red. ARRI has a RAW format, so you may run into this in the field. It tends to be a cinema style of working, and that's in large part because of the implications of the codec. It's why these two have found each other, because RAW codecs are going to take lots and lots of disks. So you're going to have expensive media. You're going to have to swap out drives fairly regularly. And then because of this Bayer pattern, you're going to have to develop the shot in post. You're going to have to convert it, de-Bayer it back into a video signal. And so all of that looks a lot like film. You have someone loading drives constantly. You have to deal with storing them. You have the cost of them. And then you have this develop stage where you make your daily later. And so, this fits very well with that cinema style of working. File sizes are huge. Quality is great. You just have to balance those two. When you're working with INTRAFRAMEs, this is what the high-end video is. So think of your Blackmagic, your REs, all of those direct-to-disc recorders you put on top of cameras are going to record to an INTERFRAME codec. Most ENG video cameras, like the news gathering, large cameras, they're going to shoot to something like ProRes, DNxHD, AVC Intra, XAVC. These are the various manufacturers' INTRAFRAME codec. And the advantage of that is that it's a good middle ground. It's the kind of codec that you can drop right into your edit system and start editing. Media is still going to be a problem. You're going to have to shoot on faster drives, either the really fast SD cards or SSD, but the quality is still great. And it's really the sweet spot for a lot of people, especially as the cost of these sort of cameras have come down in recent years. And the last of the three is INTERFRAME. So INTERFRAME is what's going to be used in a lot of the video cameras that, it's really moving up market. So years ago, HDV was the first INTERFRAME codec that moved into video. And it was a huge deal. There was lots of gnashing of teeth and rending of garments when HDV came out, because people traditionally think that INTERFRAME codecs should not be used for editing. There's a good technical reason why they don't make sense as an editing format. Because the frames are based on each other, you have to pull them all in order to decode a frame. And so that's going to mean that even though your file sizes are smaller, your bandwidth can end up being higher because you have to pull the frames in, especially if you're shuttling around. You have to pull an entire GOP of pictures, which is a group of pictures. So every frame that frame is based on has to be read off disk and decoded in order to rebuild a single frame. It's going to mean cutting's a little harder, things like that. But the advantages are huge, which is why it's moving more and more up market. The media is much cheaper because your file sizes are smaller. You can start recording to consumer media like SD cards. You can have really long record times. And this stuff has become really commoditized. You've got DSLRs, GoPro, iPhones, Androids. Lots of these things are shooting to these INTERFRAME codecs. And part of the reason of that is because of the volume of things like GoPro and the iPhone, chipsets have come out which mitigate the encode complexity. So these INTERFRAME codecs are hard to compress, but if you create custom silicone, which is on the market now, you can slide that down into a real-time operation with low battery power. Same with playback. You can have hardware accelerated decode of an INTERFRAME codec, and that drastically mitigates these problems with encode and decode complexity. And you'll see that sort of being adopted across the board. It's one of the reasons why we've been able to solidify on single codecs, is because the hardware exists now. No one wants to stray from it. And so those are your three options. And what you choose on the production end, on the acquisition end, is going to change what your options and what your best choices are for the post-production side. Going back to this original graph, the thing that we really care about in post-production is playback quality. So your transcoded render, for the most part, is behind you, because that was the cost of compressing into this format, which was most likely done on camera, unless you're transcoding to a new format, which we'll talk about in some of these workflows. But playback is the important thing. If you've got a lower decode complexity, then you're able to cut more streams of video, you're able to scrub better, you're not going to have beach balls and hangs, and you're going to be able to do your final layoff later, faster, things like that. As long as playback is real time, file sizes can vary drastically between these workflows. Quality can vary drastically. The other big thing that you want to consider is whether or not your host applications can all use whatever your codec of choice is going to be. So you don't want to lock yourself into a workflow that can't be used as you move these files around between different applications. It's best to choose one and go from there. And so I've changed the names on the graphs again for production. So what was encode complexity, we're going to call transcode and render now. What was decode complexity is playback performance. Compression is still file sizes, and quality is always just going to be quality. So if you're working with uncompressed or RAW, usually you would do this because your camera was shooting RAW. So if you have a RAW workflow where you're acquiring in RAW, some people choose to take that all the way through their workflow. It's really simple to take the SSDs from your shoot, transfer the media to your local RAID, and just start cutting. And some of the hosts will let you do this. You can debayer on the fly, play back right in your timeline. And it's very simple. The disadvantage is that it's very IO intensive. So you need a very fast machine. You need very fast storage. But if you're doing heavy effects or you're going to a color correction and you want all of that information available later, it can be a good workflow. The flip side of that is a proxy workflow. So you take your footage, maybe you want to be able to cut on a low-end machine, you want to be able to have all your media on your laptop so that you're portable. So a proxy workflow is going to take whatever your source media is and transcode it into small, low-quality imagery. The advantages of this are it's very lightweight. You can fit it on internal drives. You don't have to worry about input-output performance. You don't have to worry about the GPU on your machine. The disadvantage is going to be the quality. The quality is going to obviously go down drastically as you lower your file size. The idea behind a proxy workflow is you use this as an intermediate stage, and then at the end, you go back to an uncompressed or raw workflow. So you're going to take your original media and relink it in your color correct or your finish edit. And so this was the traditional television film workflow in the past. You would cut in some sort of proxy codec and then you would conform in finishing. It's becoming less and less common, but it's still an option. It's a great option if you need to cut on your 11-inch Air on a plane. It's great. The new one that people are starting to try is what I'm calling mix and match. I don't want to start throwing trade names for this, but the idea behind it is you take your footage as it came off the camera in whatever format, INTRAFRAME, INTERFRAME, RAW, and you toss all of it into your host app, and your host app just plays it back. You can mix and match. You don't worry about converting to some mezzanine codec or proxy codec. You just play it as it is. The advantages are great. You don't have to worry about transcoding the media. You can start cutting right away. You can throw stuff into a timeline in the field. It's great for doing, sort of daily screenings and stuff like that. The disadvantage of it is because you're leaving all your footage in its base codec, the performance profile of your project is going to vary wildly between projects. Unless you're always working with the same camera and you're always cutting the same type of cut, it's hard to develop sort of an intuition about whether or not your computer is going to be able to handle this particular project. Because the codec changes, the complexity of the playback is going to change and the file size is going to change. And so really everything is up in the air. This is one of those things that demo is great because the first 10 clips drop in the timeline and play back and everything's great. And there's always a number that your computer won't be able to do. Most likely, unless you've tested heavily with this particular set of media, you're not going to know where things start to fail until you hit it. So the complexity is additive. As you add clips, your timeline is going to slow down more and more. But the advantage is there's no transcode, there's no quality degradation. You just go. If you're going to a finish, you've got your original camera media ready to go. And so for some productions, it's a great choice.
Now, isn't this something that most new NLEs are now pushing, that they're saying they can do this?
Yeah, they are. And that's what I was alluding to with the fact that it demos really well. What we find is that, there's always a point where it stops working. And the other disadvantage of it is that when you have heavily compressed media, interframe media, you pay a performance hit every time you play that media. And because it's more computationally intensive to decode, it means you're going to burn more CPU cycles or GPU cycles or hardware acceleration cycles every time you hit play on your timeline. It also means you're going to incur that cost when you do layoffs as well. So, one way to think about this is shooting ratios. So if you have a ton of footage and a very small edit, it may make sense to take all the media in the mix and match format, because that way you don't incur the transcode penalty on a giant corpus of media. But if you're closer to a 1-to-1 shooting ratio, as you get closer to 1-to-1, if you can incur the cost of that decompression of that heavily compressed content once instead of every time you hit play or every time you make a layoff, because that's the other problem is when you render out a layoff, you have to add in all of that decomp for all of the media in your timeline. And so if you're working in a heavily compressed source format, your layoffs are going to take more time. And from my experience, you have more wiggle room in your production schedule at the head than at the delivery. When it's time to make the 14th layoff for approval, is usually not when you have an extra hour to burn decomping video. So the next model is what we call mezzanine codec. And this is sort of what we like to encourage people to use. And part of that's because, we make a tool, Edit Ready, which converts all of your camera source media into mezzanine codecs. That's really the point. And so, we're not impartial about this, but we think that for most people, this is the best workflow. And the idea behind it is you transcode your content as it comes into a single format. So that format is going to be a mezzanine codec. What I mean by mezzanine codec is it's a term from back in the network days. So a network would choose a mezzanine codec, which meant anytime footage comes into our system, it gets transcoded into this format. So in the old days, that used to be DVC Pro or DVC Pro HD. Now the two main mezzanine codecs are ProRes and DNX HD. If you're on Windows, Cineform is a mezzanine codec that a lot of people use. It doesn't really come up on Mac very often. And the idea behind this is that because you've transferred all of your media into a single codec, one, you can build up sort of an institutional knowledge base and tool set because you know all your tools are always going to support this format. You can build up an intuition about what, I know, an hour of this footage is going to fit on my drive. I know that 4 tracks of this are going to play on my laptop. The advantage of this is that you do incur that transcode penalty at the head of your workflow, but in exchange for the rest of your post-production, you can sort of plan on a little, it's more stable. The other thing is that a lot of these cameras, as we talked about before, are starting to shoot to these mezzanine codecs because they're so great for editorial. These mezzanine codecs are all INTRAFRAME codecs. So the idea is they play back very well. They play reverse and forward. They scrub easily. Every frame takes the same amount of space on disk, which is nice because it means that if the beginning of your file plays, the middle of your file will play as well. Isn't true of the INTERFRAME codecs. They may change wildly between frames what the actual size of the frame on disk. This is what we recommend as a model. So the mix and match format has been pushed a lot by the host because it demos well and because it's going to move that way. I was talking about before how HDV was something that people spent a long time railing against. And now no one would think twice about cutting HDV because computers get drastically faster every year. The thing is, what we're finding now that we've gotten rid of tape-based media, as soon as you're recording to a card, the camera manufacturer has very little incentive to standardize. And so every year they can get a better quality image for the same bit rate. So they don't have to charge the customer more for a card architecture or all these other things. But what that means is that every year, as your computers get faster, the complexity of your media decode sort of keeps pace. We have cameras coming out that are shooting to HEVC, which is the new H.265. And there's really not many computers that can play that back. And so we're just going to continue to see as the machines make up this difference between decode complexity, as soon as you have enough wiggle room to play back a format, the camera manufacturers are going to start creating new formats. And so mezzanine is a way to always know, especially if you're mixing and matching content, it's a great way to have a timeline of a known quantity. This timeline is ProRes. I know it'll intercut. I don't worry about color space mismatches. I don't worry about frame rate mismatches. Everything comes in. It's all the same format. I just play. And so, like I said, this is the one we tend to recommend to people unless they have specific use cases that dictate something else.
But your transcoding app is going to have to keep up with all of these new kinds of codecs. Without that, you can't do the mezzanine.
Right. And so, for instance, so EdiReady is our transcoding app to bring camera original media into a mezzanine codec. We tend to beat both Adobe and Final Cut to market with support for new cameras because it's the thing we do. We support camera codecs. They make editors. And so if you're on the bleeding edge of camera support, you're most likely going to have an easier time getting it into a mezzanine codec than waiting for a host to support it. Also because we have the luxury of not having to be real time. So H.265 camera comes out, we can convert it slower than real time into ProRes because you're not playing it back in a timeline, you're just prepping it for editorial.
Yeah, that makes sense.
So those are really your options for post-production. The last one is pretty quick, it's delivery. Delivery is heavily standardized. Two things that matter are getting lots and lots of compression and getting very fast decode. And that's because, not only do we have to make it into a real-time envelope where we can decode the frames fast enough to play them, a lot of the content consumption nowadays is on battery-operated devices, iPhones, iPads, laptops. And anytime you incur a huge decode complexity, you're going to burn down someone's battery life. And so, like I was saying before, the commodity market has been great for the hardware accelerated. encode and decode. And H.264 really is the standard bearer here. Most everything you deliver is going to be H.264. And now, I mean, one caveat here is when I mean delivery, I mean the actual last jump, the content that the end viewer is going to view. If you're producing a TV show for network or for Netflix or something, you may be delivering them a mezzanine codec. A lot of them will want ProRes on a drive or something like that. But that is not the delivery codec. They're doing that because they want to do the final encode to the delivery codec. The thing that actually comes down the pipe into the user's home is almost always going to be H.264. You know, some legacy stuff is MPEG-2, which is another standardized, heavily accelerated codec. That's what you'll get for like satellite, digital set-top boxes. H.264 is going to be everything coming off YouTube, Vimeo, Netflix, anything like that, any of the web-based content. HEVC is coming. It's going to hit us eventually. The other thing is they're going to have standardized, everything is going to be standardized. They're going to have standardized color spaces. So we're back to like the broadcast world where the colors in your file are going to be the same between files. So red is always going to be the same red. That's not true on like the acquisition or post side anymore. We have these like log color spaces and things where we're treating video more as information and less as a video signal. But by the time you get to delivery, everything's standardized. And because it's not a symmetrical process anymore, so you encode the video once and it gets decoded, in some cases millions of times, there's no incentive to reduce the encode complexity. In fact, the encode complexity is just astronomical on a lot of these delivery formats now. So it's H.264, but you do things like variable bitrate multipass, where you will go through the file multiple times in order to find the spots that require lots of bits and the spots that require very few bits. And you'll allocate the bits to that spot and take them from less visually important sections of the image or of the entire frame. And then, you know, when you get into the high-end delivery, things like Netflix, they do what are called bitrate ladders. So they're actually encoding multiple files for delivery on different devices. So in order to optimize the quality and lower the decode complexity, they will produce what are called bitrate ladders. So as many as 10 or more videos for every single video, and then they will vend the correct one based on display size, for instance, or bandwidth. And so it really is, you throw lots of computation at the encode, you encode to lots of different contingencies, all to lower the decode complexity, up the compression, and keep the quality as high as possible. So those are really the three sections of your production workflow. That's how codecs are going to tend to be used, and thanks a lot.
When do we get our PhD degree here? No, seriously, Mike, this was fantastic. It's pretty much everything we ever wanted to know and more about codecs.
Well, thank you very much.
I think it's important that people understand this topic thoroughly, even if they're, let's say, a corporate video editor or a non-filmmaker. Like you said, it will affect your workflow, your time, your delivery. It affects everything. Plus, you prepare better for post when you know what's coming from production.
For a lot of people, especially like corporate and other smaller teams, or even large teams, what will tend to happen is you choose the type of image you want or the type of on-set production you want to do, and that's going to be determined by costs and flexibility, how portable you need things to be, how big of a crew you have. And from that, you choose the best camera that you can, and then the codec decisions made by the camera manufacturer. I mean, you know, you'll have a few menu options in most cameras to, you know, you can kind of tweak this a little bit. But for the most part, the camera that you choose is going to dictate your acquisition codec. And that choice sort of percolates through post-production, which is one of the reasons we like the mezzanine model of editorial, because it means you can sort of put up a beachhead at the door of editorial and say, well, when you get here, you know, you shoot whatever you want. If the producer shows up with an iPhone on the day of the shoot and wants to shoot some pickup shots, or if somebody brings, you know, your B cameraman brings a DSLR, you know, they're like, okay, well, give me the cards, we'll transcode it to ProRes, and then it's just like any other content we've ever had.
Now you have Edit Ready, which I encourage everybody to go check it out on divergentmedia.com. You can see it here on the screen, /Edit Ready, which is your encoding software. You also have another one called Scopebox, right?
Yeah, Scopebox is our QC tool. So it's used either on set or in editorial or color. It's used a lot by colorists. It's software scope. So you can bring in a signal through a capture card and get waveform, vector scope, you know, all of these high-end QC tools. And we do a number of custom ones specifically targeting things like color casts and shadows and highlights, gamut problems. And so it really it's a more analytical way of looking at your video signal, which lets you make more informed color decisions, whether that's on set, how you light a green screen, or how you expose your highlights, or whether that's, in your color correct, to help you match shots and get around, weird problems with your image.
And you have trials for both Edit Ready and Scopebox.
Yep. So Edit Ready will work forever. It just does the first minute of every file, and Scopebox is a 14-day trial.
Well, Mike, thanks again. I really appreciate it. It was a pleasure having you here.
Thanks so much. Great talking to you.
Great talking to you too. And to the rest of you, please check out more of our tutorials, videos, podcasts, and articles. So until the next tutorial, I'm Marcelo Lewin. Cheers, everyone.